Okay. So what do we need to see from the homework?
Number 2.
Okay. That's on Newton's. Yeah. Yeah. 2 and 5. Let's have a look at them. Sorry, excuse me. Let's see. Physics workbook. Okay. Can you see okay?
Yeah.
Yeah. What's the ID number? That'll be helpful. Yeah, beside each question there's an ID number. What is it? 385? 385. There we go. A trailer of 350 kilograms is attached to a car of 800 kilograms. The car accelerates from rest to 10, 25 seconds. Determine the force needed. Okay, so what I'm going to do first is, this is a UVAT, oh dear. This is a UVATS problem. UVATS. What's the U? 0. What's the V? 10. What's the T? 25, isn't it?
Yes.
Yeah. And let's get the A. V equals U plus AT. Yeah? So that's 0.4, is it?
Yeah.
But they want to know what the force is. And force is MA. What's the total mass? The total mass is 350 and 800.
Yeah.
1150. Yeah, like this?
Yeah.
So what do we get for F?
46. 460.
460 Newton. So that part's okay. Now the second part is trickier though, a little trickier. What is the tension in the tow bar? Now, let's draw a little picture to help us. So let's say here's the trailer. And then, oh, that's my car. I know it looks more like a spaceship. Anyways, that's the car there. Okay, so if you look at the trailer, its mass is 350 kilograms and this is 800 kilograms. How many forces are acting on the trailer? Well, there's just the one force. The tow bar. Okay? In your mind, don't think that the engine is pulling the trailer. Think the tow bar is pulling the trailer. It's almost like you zoom in and this is what it looks like. You're the trailer and you just have this tow bar pulling you. Okay? You don't know anything about the car because you're a trailer. So, what do trailers know about cars? They're trailers. Okay. So, what is the acceleration? Well, it has to be the same as the car, doesn't it? I mean, it would be silly if it was less. That means well, what would that mean if the acceleration was less? What would be happening? Be detached, yeah. And if it was more? Yeah. How that would happen, I don't know, unless someone pushed it, you know. What did we say the acceleration was a moment ago? 0.4 meters per second squared. So, that tension is the force, which is the MA. So we have to multiply 350 by 0.4. And what do we get if we do that? 140?
Yeah.
Okay. Are we happy with that? Yeah. Let's look at the next question now. You said number 5 was a problem, didn't you? Yeah. A train and engine have a total mass of 2.5 10 to the 6 kilograms. It's at rest. The engine of the train exerts a force of 700 kilonewtons. So the engine has a force of 700 kilonewtons. And it accelerates until it reaches a velocity of 56 meters per second. What's the acceleration of the train? Well, I think the first part's okay, isn't it? You have the mass and you have the force. So Newton said F equals ma, right? So then that means A F over m, which is 700,000. Oh, that's a positive 6, sorry. 2.5 times 10 to the 6. So what do we get for the A?
0.28.
Thank you. Okay, I think that's okay, isn't it, for the first part? The time taken, well, that's just going to be UBATS 0.28, 56. Well, give us the T. V equals U plus AT, won't it? V equals U plus AT. 200 seconds. Okay. And finally the distance. Oh, okay. I think the best thing would be U plus V over 2 times T. 5600.
Yeah.
All fine, I hope.
Question 2 on weight and drag.
Question 2 on weight and drag. Okay. You got number 1 okay?
Yeah.
Yeah. Number 1 you have to describe, wasn't it?
Yes.
Yeah. Can I scroll down? Was number 3 okay? Yeah. Uh-huh. Well, part A is fine. What's the definition of a Newton? A Newton of force is what causes 1 kilogram to accelerate by 1 meter per second squared. So we gave you that definition in class yesterday, didn't we?
Yeah.
Right, let's have a look. Is it the B or the C?
B.
B part, okay. Right, so this is ID 30. Okay, B. A firework rocket of 0.3 is launched with an acceleration of 50. Determine the resultant force on the rocket. Okay, so we have to be careful here because there's actually 2 forces. There's a thrust and there's a weight.
Right.
And it doesn't mention anything about drag just yet, but there might be later. We know the mass is 0.3 kilograms. Now that 50, I believe, would be the total acceleration, obviously. In other words, if I use F equals ma, this F here is not T, and it's not W, but it'll be the total, T minus W. The net force, remember? So F equals ma. T minus W equals ma. And they want the now see what actually they don't care about the T or the W, they just want the total F because they use the word resultant. Remember what resultant means? Yeah, the result, yeah, you add them. So actually I just need to calculate MA, it looks like. 0.3
Times
times, what did they say? 50.
Yeah.
50.
Yeah. Okay, so what's that? 15?
15.
15 newtons. Now that 15 is the result of T minus W. It's not T and it's not W. Now maybe they ask you for T next, do they? Yes, they do. So T would be W plus 15, which would be mg plus 15. And what do you get for that? Say again? Thank you. Like that. Okay? As the rocket falls back to Earth, it reaches a constant speed. Give the term for this.
Terminal velocity.
Yeah, terminal velocity. Oh, you know what? Why am I even writing it? And explain why the object falls at a constant speed.
So drag equals thrust.
Yeah, drag equals thrust. Or in this case, it would be drag equals weight. Yeah? Okay, are we happy with all the homework then? Yeah? Yeah, okay, good, good. Yeah, the next lesson is a hard one. Let's close this. Do you guys know anybody from intake